Assalamualaikum. My name is Syahmin bin Ahmad Izzaudin.
And I am Midi bin Ismail.
We are from class PE 2005B1, and for today we will be presenting the assignment for ESE 551, which is task 2, MATLAB execution.
For question A, by using MATLAB and Control System Toolbox, plot the root locus for the system and indicate the break-in or breakaway point, imaginary axis crossing, and angle of departure or angle of arrival, and then identify the range of K for which the system is stable. Step 1. Open up MATLAB and enter the command. For step 2, we will then put a rlocus command to get the root locus graph. Step 3, proceed to adjust the point to obtain the value of 30 for the gain. Based on the result obtained, the system is considered stable due to the pole being located on the left side and none of them on the right side. Since the poles are located on the zero axis, there is no break-in point, but the breakout away point, however, is located at the pole axis. Because there is no complex zeros and complex poles, the angle of departure and angle of arrival also does not exist.
Question B. Write a MATLAB program to assess whether the point S equal negative 0.17 plus 1.7i is located on the root locus of the system. Include the step response at the operating point to show the system transient response characteristic. Step 1. Return to the command window and enter the same command as in question A. Step 2. In the root locus graph, move the pole so that the value is S equal to negative 1.7 plus 1.74i as shown here. Based on the result obtained, S equals negative 0.17 plus 1.7i is located on the root locus of the system since the value of the gain is 17.3. Step 3. Return to the command window and enter the command sysotoolg. Step 3. The point in the root locus graph is adjusted to obtain the value of S equal to negative 0.17 plus 1.74i as shown here. Next, open up the plot tab to obtain the necessary information such as settling time, peak time, and percentage overshoot. Based on the result obtained, we concluded that the value for each requirement is as follows. Settling time is equal to 22.1 seconds, peak time equal to 1.98 seconds, and percentage overshoot is equal to 69.8%.
Question C. By using MATLAB and sysotool or Control System Toolbox, prove that the designer lead compensator in task 1C has met the criteria. If not, please slightly adjust the compensator gain, pole, and zero to achieve the desired criteria. Include the plot of compensated root locus and compensated step response.
Step 1. Open up the command window and enter the same command as in question A. Open up the root locus graph and add the lead compensator by right-clicking the root locus graph, add pole/0 and lead as shown here. Next, open up root locus start in order to adjust the settling time to 3 seconds as shown here. Next, we will also be changing the percent overshoot of the root locus by changing it to 15%. Open up the compensator editor in order to put the value of real zero and real pole according to calculation that have been done in the theory part and adjust the value of compensator. Lastly, open up the step response graph to be presented with the result as shown here. Question D. By using MATLAB and SysOtool or Control System Toolbox, prove that the design LED compensator in task 1D has met the criteria. If not, please slightly adjust the compensator gain, pole, and zero to achieve the desired criteria. Include the plots of compensated baud plot and compensated step response.
1. Enter the same command window as previous and use CISO tool. To add the LED compensator, start off by right-clicking the root locus graph, then add pole or zero, and then use LED. Next, change the percent overshoot to 20%. Adjust the pool until it intersects with overshoot 20. Open up the step response graph and add the characteristic. As we can see, the overshoot at the step response is 20.6%. Open up the baud plot graph to obtain the value of phase margin and gain margin. Based on the result above, the value of PM is 47.5 and the value of GM is 15.6 dB.